Okay, so 3b has us implement sandworm, which is a function that takes in a non-negative integer n and returns the largest worm that appears among the digits of n in order, but not necessarily formed of adjacent digits. And the way you compare the largest worm is just by the numerical value, because worms are essentially integers that satisfy a certain property. Okay, so just because this is a little bit more complicated than the previous parts, let's just run through this doc test as an example. So in this case, the biggest worm inside this number is actually just going to be 5, because we know that there's no kind of two consecutive integers here. So the biggest worm is just going to be the biggest digit. On the other hand, with 152, the biggest worm that you can form is 1 and 2. You can't use 5 because they're always going to be more than one distance away from the other two numbers. But the reason why you can use 12 is because it specifies in the problem that you can make the worms that are not necessarily formed of adjacent digits as long as they're in order. So now that we kind of have a sense of what the problem is asking, let's take a look at the skeleton. So it seems like this is a little bit more of a complicated example of recursion, because not only is it recursion, but we're also, we have like an instance of higher order functions, because we're asked to implement sandworm, but sandworm actually has two other functions defined inside of it. Yeah, and one of them is already implemented for us, and another is something that we will have to implement ourselves, which is tooth. Okay, so for now, let's just disregard what's going on inside these nested functions, and let's just look at what sandworm does by itself. So sandworm has this base case where if n is equal to 1, then return 0. And this makes sense because if our n that we passed in is 0, well, the largest worm that we can make with 0 is just going to be 0. Cool. So we can kind of ignore these other functions for now, because we don't have to go into them until we actually call one of the functions. So I'm just going to go down until we get to a call, which is right here. So we're returning the max of two things. One is something that we have to figure out, and another is use last on n. So the names are actually pretty useful here. Use last essentially returns the largest worm in n that includes the last digit, which is n mod 10. So if we want the maximum, like the largest worm, we can kind of think of this as splitting up into two cases. One, which is the largest worm that includes the last digit, and one which is the largest worm that doesn't include the last digit. And we know that the bigger of the two is going to be the largest worm overall, because a worm has to either include or not include the last digit. They're sort of mutually exclusive and collectively exhaustive. So if we were to take the max of the worm that uses the last digit and the worm that doesn't use the last digit, well, the way we get the worm that uses or that doesn't use the last digit is just going to be calling sandworm on n floor div 10, right? Because that kind of calls, that returns the largest worm of n, but n in this case doesn't include our last digit anymore. And this is a really important pattern to kind of be able to recognize and feel comfortable with using. And we've seen this a lot in 61A already, right? With like problems like count partition or count coins, essentially where you're trying to solve for all of the different combinations, and the way you count for all of those different combinations is by either using an element or not using an element. So in this case, we're counting all of the different sandworms and finding the max between sandworms that use the last digit and sandworms that don't use the last digit. Cool. Now we can kind of look at what was already given to us, which is this use last on n. Use last returns the largest worm in n that includes n mod 10, which is what we already went over. But the implementation for this is it returns a call on tooth that passes in n floor div 10 and n mod 10. So what tooth is going to do is it's going to return the largest worm formed by some digits of n followed by the digit d. And the digit d here is essentially always going to be the last digit of n. Okay, so let's just look at tooth now. So what we have is another instance of our recursive structure. So we have our base case and our recursive case. The base case here, if n is equal to 0, well, we just want to return the largest worm formed by the digits of n, which is 0, followed by the digit d, right? So if n is 0, then the largest worm is just going to be d. So we're going to return d. Now let's look at a recursive case. So if you remember from the problem, it says that you could form worms that contain digits of n that are not necessarily adjacent. So this means we can kind of skip different digits if that created a worm that was bigger, right? So essentially we're left with the same problem as before, where in order to count all of the different possibilities, we could either skip a digit or use a digit, right? It's the same pattern as we did before with using the last digit or not using the last digit with our sandworm example. So in this case, how are we going to return the largest worm formed by the digits of n followed by digit d, where we skip the last digit of n? Well, this is just a recursive call to tooth that passes in n mod 10, or sorry, n floor of 10 and d. So that's our worm, our biggest worm without using the last digit of n. Now, if we did want to use the last digit of n, there are a couple of constraints, or like one constraint that we need to keep in mind, and that's that last digit has to be at most, or it has to be exactly one digit away from d, because we're going to use d as our last digit. So you have that kind of condition stipulated in this line where it says if near on the last digit of n and d, so that means if they're one apart, then we're going to return the max between skip, and now we're essentially allowed to use the last digit of n because it satisfies that near condition. So how are we going to make the largest worm that uses the last digit of n and then tack that d on after? Well, the way we get the largest worm that includes the last digit of n is use last, right? So if we were to call use last on n, that would give us the largest worm in n that includes the last digit of n. But we don't want just that. We want the largest worm formed by some digits of n followed by the digit d. So we want to add d at the end, but in order to have all of these numbers kind of shifted over, so d is in the last least significant place, we would have to multiply use last by 10. Okay, so that's going to be what we're comparing between skip, which is the biggest worm using d that doesn't use the last digit of n, and this expression, which is the biggest worm that uses the last digit of n and then tacks on that digit d. So those were all of the blanks that we had to fill in for this problem, but since this is a pretty complicated problem, I thought I would now just kind of go over some of the most common misconceptions. So first, why is it possible that we can kind of split this up between using the last digit of n and not using the last digit, right? Because it says in our original problem that we can form the largest worm that appears out of any number of digits in order, where you can kind of like skip the first two digits, you can skip the last two digits, you can skip one digit in the middle, one digit at the end, like you can skip any kind of combination of these digits, right? So why is it possible that just by splitting the cases up into skipping the last digit and not skipping the last digit, that we take into account for all of these possibilities? So the reason why this works is because essentially this is another recursive call, right? Skip is another recursive call to tooth that takes in n floor of 10, so getting rid of the last digit, and d. So you can kind of split these calls up and like draw out the recursive tree where you're doing skip and no skip. But skip is another recursive tree where you call, again, skip 2 and like no skip. And then this, like, they all are essentially recursive calls. So the reason why just skipping the last digit includes different cases where like you skip the last digit and then you skip another digit like 3 digits later is because since these are all recursive calls, you can kind of think of it as taking the max at each branch. So this is like the max of this and this. Okay, these lines are getting confusing, but you're taking the max at each branch. So say if you were to follow this line where you're doing skip, skip, and then no skip, and then skip. Here, right, we're skipping the last digit. We're skipping the second to last digit. We're not skipping the third digit, not skip 3, and then we're skipping the fourth digit, right? But you can, this is just some arbitrary like path that I've drawn out, but we're taking the max of all of these different paths with our recursion. So that's why it's so powerful to have this pattern where you're just kind of including the last element and discluding the last element and summing up all of those recursive calls, because you can kind of traverse down all of these different paths in our recursive tree and essentially account for all of the different combinations of options that we have. So the second point of confusion that students often have is, how do you know which recursive function to call? So for example, how do you know that you should be calling tooth here and then use last here, but then sandworm here, right? And there's no real like universal rule to figure this out. It really depends on just what you want. So because of this, I'll just go over the specific cases that we were given in this problem. So for this, for example, this last case, where you have returning the max of sandworm and use last, the reason why we wanted sandworm here is because we want a way to return the largest worm that doesn't include the last digit, n. And sandworm is the only way to do that. So if you were to, for example, call tooth instead, well, tooth returns the largest worm formed by some digits of n followed by digit d. So that's like an additional constraint, the followed by digit d part, that we don't want to consider for this part. So now what about the case where you're, right here, where you're calling tooth now? So the reason why we call tooth here is because, first of all, we're inside the function tooth, so we want to return the largest worm formed by some digits of n followed by the digit d. So if we want to accomplish this goal, the only way we can do this is by using tooth, because if we were to use sandworm here, now we're getting rid of this digit d that we already like said that we want to return, or that we want as a part of our solution. So the only way to kind of keep this d here would be by calling tooth. And finally, for this third arrow here, well, in this line we're returning the max between skip and the one where you do use the last digit of n. And what's the one where you do use the last digit of n? Well, that's just going to be a call to use last. So that's why we use last here. So yeah, as you can see, there's no kind of rule that you can apply. It's really just you have to look at each case individually and see what you want and which function matches that. So hopefully that cleared up some confusions for you guys, and yeah, that's how I would approach problem 2b.